Soalan 7, a mixture of propane and bromine is exposed to sunlight. The reaction equation is given. Propane react with bromine in the presence of UV, producing two products A and B. State the type of reaction. Okay, for alkane, it only can undergo substitution because of all of the bond in alkane are single bond, so it don't have double bond. That's what so we are undergo substitution reaction. But who substitute the hydrogen inside the alkane? So if you have UV will break bromine homolytically to produce free radical. So the free radical will substitute the H. Therefore, it is free radical substitution reaction. B, what is the function of the sunlight? So UV is used to break the bromine homolytically, provide energy for the homolytic cleavage. Okay, C, draw the structure of mono-substituted A and B. Then identify the major and minor product. Okay, bromine can be substituted at the first hydrogen at first carbon, or substitute hydrogen at the second carbon. Let's say this is hydrogen. Another one is okay. If the bromine attached at carbon number 2, that means the bromine is bonded to the free radical of alkane at the secondary free radical. Another one is the primary free radical. So if bromine attached here, we will form bromine at carbon number 2. If bromine go to the primary free radical, then bromine at carbon number 1. Okay, which one is the major and minor? To determine major and minor, we look at the stability of the free radical before the product form. Just now, I draw the free radical. It is secondary free radical, while the other structure is come from primary free radical. So as we learned before this, the previous chapter, the secondary free radical is more stable than primary free radical. It's due to the presence of more alkyl group, which is electron donating group, that keep donating the electron to the carbon with unpaired electron. So it is more stable compared to the primary free radical, where it only has one electron donating group. So only one donor donate electron to the carbon with unpaired electron. So secondary free radical is more stable and produce 2 bromopropane, and this is the major product. Why is it major product? Because more bromine will attach to the carbon with to the secondary carbon. So it is more favorable to undergo reaction. Since it is more favorable, then the reaction will be the product form will be the major product. The other one will be minor product. So major is come from the intermediate, either it is free radical or carbocation that is more stable. So the more stable the intermediates, it will form major product. So we will have major product here. Bromine at carbon number 2 as a major product, and bromine at carbon number 1 as a minor product. Next is to write the mechanism for the following formation of the major product. We have 3 steps. Number 1 is to the initiation step. In the initiation step, okay, the most important thing is the UV. Okay, so look at how the bond break. UV will break bromine homolytically. One bond consists of 2 electrons. One electron will go to this bromine, another one will go to the other bromine. So we are producing 2 bromine radical. Next, the bromine radical sangat jahat. Dia buat apa? Dia akan attack yang neutral. Okay, so keyword untuk propagation adalah attack free radical, attack neutral species, such as the alkane. Since we want to substitute the second hydrogen at the second carbon, so we expand the second carbon part. So attacking is like this: bromine attack and then cause the carbon hydrogen bond to break. Okay, let me zoom. One electron will go to carbon, another one electron will go to the hydrogen. Since the hydrogen break, hydrogen will form hydrogen radical and then it's combined with the Br, so it will form HBr and leave the carbon to be unpaired like this. Okay, so this carbon, secondary carbon, got one electron, so it become free radical. Next, this alkane radical will, okay, let me copy this one, will attack another neutral species. So kita ada neutral species yang lain, iaitu bromine yang belum break lagi. Okay, so dalam tindak balas tu bukan hanya ada satu molekul bromine, tapi sangat banyak, beribu-ribu mol. Dalam satu mol bromine tu ada banyak biji bromine molekul. So dia akan attack bromine yang radical. Okay, contohnya dekat sini, bromine radical yang jahat attack alkane yang neutral. Sekarang alkane radical attack bromine yang neutral. Okay, ingat, free radical attack neutral species. So macam mana kita nak tunjukkan dia attack? Dia attack macam ni, menyebabkan bromine ini break homolytically, anak panah keluar. Keluar means bond breaking. So CH3, CH3, and then making a bond between carbon and bromine, plus the other bromine left here, the bromine here will be bromine radical. Okay, so this bromine radical akan attack lagi yang neutral, sama ada bromine yang neutral like this, or bromine radical ni akan attack alkane, ataupun alkane attack bromine. So as long as we are producing the free radical keep on attacking the neutral species. So that is the propagation step. Ada banyak lagi equation yang kita boleh tulis untuk menunjukkan free radical attack yang neutral untuk propagation step. Okay, since we keep producing the free radical, we need to stop this reaction. So how we stop the reaction? We need to undergo the termination step, which is to stop the reaction from producing another free radical. Okay, now let us list down the free radical that we have produced. Okay, in our propagation step, we are producing two types of radical, which is alkane radical and bromine radical. So these two type of free radical can have three combination of radical. Okay, first we can have radical and radical, radical and bromine. Okay. This one is radical and radical combined together. The second one is radical and bromine radical. The other one is third combination, bromine radical and another bromine radical. So to make a bond, we need to show the arrow, both of the arrow meet together. Okay, this one. When they meet, they form a new bond. Okay. So this one will be Br bond Br, ataupun you boleh tulis Br2. The other one is CH3. And then this is the new bond form, Br. Carbon form bond with Br. The other one is alkane radical combined together with another alkane radical, CH3. Okay, so this is the first one. So I rearrange into like this, into this part. So yang ni saya adjust pergi bawah, so that the unpaired electron duduk kat tepi ni. The other one pun sama juga, saya twist this one. I make this one with blue color. So this is the radical, ada H, ada CH3, ada CH3. Okay, sekarang bila dia gabung, kita form bond antara radical dengan radical. So kita dapat alkane yang lebih panjang, yang bertambah bilangan karbon. Right, itu saja untuk free radical substitution mechanism.